Hi everyone, we've got a key type of question here for circles at A level. Really important, kind of one of those 3 or 4 key types of question that students find tricky. So let's have a look. It says a circle C has the equation x minus 5 squared plus y add 3 squared equals 10. The line L is a tangent to the circle and has a gradient of minus 3. Find the 2 possible equations for L, giving your answer in the form y equals mx plus c. So first of all, it's important, let's get a sketch, okay, and see a picture of what's actually happening here. And we've got a sketch here and we can see there's our circle with our center 5 minus 3 and a radius of root 10. And we've got our 2 lines here, which are tangents to the circle, and they both have a gradient of minus 3, so they're parallel to each other. Now, a key way into this question, I don't think it's necessarily that obvious, but the key way into this question is to let's find the equation of this line here that is perpendicular to both of these other lines and goes through the center of our circle. Now, we can do this because we have the grade. In order to find the equation of a line, we need 2 things. We need a point on the line and we need a gradient. We have a point on the line, the point 5 minus 3, the center of the circle, and we can easily deduce the gradient of this line because it's negative the reciprocal of the gradients of L2 and L3. So therefore, as they have a gradient of minus 3, we flip it and change the sign, so the gradient of this one is 1/3. Okay, so now let's use the equation y minus y1. You can use y equals mx plus c if you prefer, but I'm going to use y minus y1, sub in the equation of my point, my 5 minus 3, and my gradient 1/3. And when I do that, expand the bracket, I find the equation of L1 is y is equal to 1/3 x minus 14/3. So far, so good. So in order to find now the equation of L2 and L3, I could do with knowing a point on the line as well as the gradients. So in other words, I now need to find out what are the coordinates of these 2 points of intersection. And in order to find out the two points of intersection, I need to sub in the equation of my line, L1, into the equation of my circle. So I'm going to sub now the equation of my line into my circle and solve it in order to find the coordinates of the 2 points of intersection. So we have our equation of our circle is y minus 5 squared add y add 3 squared is equal to 10. We're now going to sub in the equation of L1, the line, like the L1. So that's going to be 1/3 x minus 14/3 plus 3 all squared equals 10. Okay, which gives us 1/3 x minus 5/3 all squared. We have x minus 5 squared equals 10. And now we can expand this whole thing. So that gives us x squared minus 10x plus 25 plus 1 over 9, 1 over 9 x squared minus 5 over 9, and another 5 over 9 is 10 over 9x plus 25 over 9 equals 10. Then we can collect all of our like terms. X squared add 1 over 9 is 10 over 9 x squared. Just cancel that out to show I've dealt with it. Minus 10x minus 10 over 9x is going to give us minus 100 over 9. Minus 100 over 9x. There we go. Yes, that's right, because it's 90, add another 10. And then we're going to have 25 plus 25 over 9, which gives us 250 over 9. So 250 over 9. There we go. Okay, is all equal to 10. Now, it makes sense at this stage to times everything by 9 to get rid of all these fractions. So we're going to have 10x squared minus 100x plus 250 equals 90. Let's get the whole thing over one side. 10x squared minus 100x plus 160 equals 0. Divide everything by 10. So we have x squared minus 10x plus 16 equals 0. And that's really nice. So that's kind of like boiled down to a very nice one. And you know what? This might even factorize. So let's see whether or not we can now factorize this. We're looking for two numbers that times together to make positive 16 and add together to make minus 8. So that could be add together to make minus 10, sorry. So that's going to be minus 8 and minus 2. So that's going to factorize into x minus 8 and x minus 2 is equal to 0. So therefore x is equal to 8 and x is equal to 2. Perfect. So we've now found the two x coordinates. So we now need to go back to the equation of our line, okay, in order to find out the two corresponding y values. So we're going back now to use the equation of the line, which you might remember was y is equal to 1/3 x minus 14/3. So now we're going to have y is equal to 1/3 times by our x, which is 8, minus 14/3. And when we work that one out, let's see what we get. We're going to get 8/3. So we're going to have 8/3 minus our 14/3. 8/3 minus our 14/3 is minus 2. So we have minus 2 for that one. This one is going to be y is equal to 1/3 times by 2 minus 14/3. And when we evaluate that one, that gives us minus 4. So we now have our two coordinates of our points of intersection, okay? So let's look and see what they are. So we've got 8 and minus 2, and we've got 2 and minus 4. So we have here, one of the points is 8 across and minus 2, and the other one is 2 across and minus 4. So that one is 2 and minus 4. So we found those 2 points now. So now that we found them, we're in the position now to find the equation of the two lines L2 and L3. We've almost done the question now. So the next bit's all over by the shouting, as they would say. So we can now work out what's going on with our other two equations. So let's do that. So let's do L2. So the equation for L2, the one that I've called L2, is going to be given by, we're going to use the point 2 minus 4 rather, and the gradient of minus 3. So we use y minus y1 equals mx minus x1. So therefore y minus 4 is going to be y plus 4 is equal to minus 3 times by x minus 2. Okay, so from this we've got y add 4 equals minus 3x add 6. So therefore y is equal to minus 3x add 2. Perfect, that's the equation of one of those lines. Let's do the other one, the one that I've now called L3. That is the coordinate 8 minus 2. And we have a gradient of minus 3. So again, using y minus y1 is mx minus x1. We have y minus minus 2, which is y plus 2, equals minus 3 times by x minus, in this case, 8. So therefore, y add 2 equals minus 3x plus 24. So we're going to have y is equal to minus 3x add 22. And that's the equation of our other line, L3. And we have now completed that question, okay? I hope that you found that useful. Let's just have a key run through the key elements. So the breakthrough into this question was thinking of this line here, which is perpendicular. Because once we found the equation of this line, we were able to sub it into the equation of the circle to get these 2 points. Once we got these 2 points, we then had a gradient and a point, and we were able to find their equations as well. So look out for that. That's a key kind of question that comes up in this topic. I hope you found that video helpful, and I will see you in the next video.